Hello, class. Good morning. And today we are going to discuss on the new topic of the linear list implementations, and that is a queue. In the previous class, we have discussed about the stack that work on the LIFO manner, that is a list in last in first out. And now today we are going to see queue that is a linear list implemented in the FIFO manner. FIFO manner is about first in, first out, where insertion takes place as the rear end and the deletion are restricted only to the front end. Like a stack, here deletion is not restricted at the last point. Here insertion and deletion both we will do from the starting point. From the starting, we will do the insertion also, and from the starting, we will do the deletion. The both we will do on the starting point. And there is no any other method to delete the data from the queue. We will delete from the front end and we will insert from the rear end. What is the front end and the rear end? We have a two pointer variable in the queue. That is the rear and front. When the queue is empty, rear and front both we will set on the null position. Null position is indicating the queue is empty. Either null position is on the rear or is on the front. If both having or any one having, that means queue is empty. But we have to set in such a manner the rear and front both will go to the null position. And if there is a item, then rear and front both will move according to that. So that is called as a what? Rear and front. So here, first time when we will insert any data on the queue, the rear and front both will move from the null position to the zero position. Then after, when we will do the again insertion, so the rear will move, the front will still on zero position. Again and again we will insert, again and again rear will move. Now, at the time of deletion, when we will do the deletion, we will use the front variable. And we will do the deletion from the front side. So when we will delete any item, the front will move from first position to the next position onwards. And the deletion we will do till that the value of front and rear is not equal. That means we have to arrange the list in such a manner that the front is a one step backward to the rear. Then both are on the same position, and if the deletion is performed, that means we have deleted all the items. Clear? So if we have deleted, both are on the same position, and again we will set rear and front to the null position, so it indicates the queue is empty. In the queue, we are performing three type of operations. The first one is a in queue, and another one is a dequeue. The third one is a pick, and the last one that is a display, that we will display the value between front to rear. In queue means when we will say in queue 5, that means we are inserting 5 into the queue. When we will say dequeue, that means we are deleting one item from the queue. So my dear students, always keep in your mind, when in the queue, in queue function is called in queue, that means ENQUE, again UE. So that is called we are going to insert. So we will not make any functions like insert delete. We will make in queue and we will make a function dequeue. So that is the insert and delete, and the pick function will display the value that is on the what front position, means first position value. If we want to see, then we have to call the pick function. The pick function work is only to display the first value of the queue. So here we have to implement. So once again, I will show you here how to we will make the queue function. So we are going to make few implementations. In that, we need three variables. The first one is a queue variable, that is of list. The second variable is a rear, that will on the null position. And the third one is front, that is also on the null position. So to implement the queue, these three variables are required. Now, the functions that we will make for the queue is that one. First, we will make a enqueue function. This function will use to insert the data inside the what. The next one we will make dequeue. This function will use to delete the data from starting position. From starting position. The third function we will make pick. This function will display the starting position value. Starting position value, that means we will display the we will display the front position value, the front variable, front index value. For example, look here, this is our list. I will tell example. And the list is empty. So what is the position of rear and front? The rear is on the null position and front is also on the null position. Step 1, we are in queue 5. In queue 5 means I told you, so we are going to insert 5. So that time the 5 will insert here, and the 5 will insert here. So here, what is the value of the rear? The rear is also on 0 position, and the front will also come to the 0 position. Step 2, Again, we are in queue 6. That means inside the queue 5, comma, 5, comma, what will become 6 value. And then queue is like that. That time, the rear will come to the first position and the front will come to the 0 position. When we will do the insertion, my dear students, only the rear value will move. The front value will remain same. Now, the third, we have done DQ. So DQ means deleting. So when we will delete, so look here, when we will delete, that time in the queue, which item will remain 6. And that time, the rear is on which variable, which position 1, and the front will also move to the which position 1. And again, if you are doing the queue, means again if you are deleting, that times what will be happen? The queue we have to make empty and the rear, and that at the time of that we will see if the rear and front both are equal. That time we will empty the queue. If the rear and front is equal to 0, yeah, we can say if the length of the queue is equal to 0, that time what we will do? We will say rear and front, you may both what? Go to which position? Null position. You may go to the null position, and else if this condition is not, so front, you may go to the what? Length of queue minus 1. That means one position forward. So we have to implement the concept of queues by that. So look here, my dear students, how we will implement into our programming. We have to make a programming concept. So look here. Here, new file. And here we are going to make a queue concept. Queue implementations we are going to do. So inside the queue implementations, what we have to make? So we have to make one rear variable. What is the use of the rear variables? In that we will write it is a which type of variable? It is an integer variable that have the index of last position of queue. Now we have a front, which is also integer variable that having position of first. Here we can frontmost element in a queue, and we have to make one queue variable implemented as a queue. So here, what things are needed? One queue variable is needed. One rear that having the null value. Yeah, you can say integer variable is there, so rear is on the minus position, and the front is also on the which position? Minus position. Then the first function I am going to make, which is empty. Is empty. In that I am passing here q, and we will see if the q is equal to this. So we will say here return true, as return false. We have made one function. Functions to check q is empty or not. So that is the end of the functions. Now I am going to make one function that name is the in queue. In queue, what it will do? In the queue, it will insert one item. So, what you will do? You will append q dot append queue item. In the list, we will append the item. Clear? And then after I will check if the length of the queue is equals to 1. So I will say a rear is equal to front, rear is equal to front is equal to 0. That means both they may go to the 0 position, else the rear will move to the length of q minus 1. So that is a function of which one? D. Now we will make definition delete q, yeah, dq. What the dq will do? Dq will take one q, and in that it may check if is empty. Now we can say if empty q condition true. So we will say print q is in underflow condition. Underflow underflow condition, that means what? It is the empty. Else, when the queue is not empty, that time what we have to do? We have to, in the data, I have to pop the item. Which item we will pop? First item, 0 position. Then I will check here if the length of queue is equal to 0. That means there is no any item. All items are removed. So all items are removed. That means queue is empty. And when the queue is empty, the rear and the front will go to the which index? -1 index. And then after, I will return the data. So this is the functions, my dear student, of the queue. We have to make one is empty functions, which will check the queue is empty or not. One functions we have to make in queue, which one is used to insert the item in the queue. And another functions we have to make, that is a GQ, which one is used to delete the queue, delete the data from the. So I hope you have understand this queue concept. Then after, there is one task to implement into the. So I hope you have understand how you have to implement the concept of the queue. And after that, we have to make a menu-based programs to call and to display and to delete the data from the queue. So that is the key point. Thank you. This is the last topic of this chapter. Now, in the next class, we will start directly to the databases. Thank you.